Limits. We begin with a simple example. Let's say you come across a problem that asks you to evaluate the limit as x approaches 2 of a function x plus 7. Then what the problem is asking you to do is the independent variable x is getting closer and closer to 2. So it could be 1.99, then 1.999 and so on. And it's approaching 2 from other side as well. So it could be 2.01, 2.001 and so on. And this is a function of x. So what happens whenever x is getting closer and closer to 2? And you might say, well, if x is getting closer and closer to 2, why not I try x equal to 2? So I plug x equal to 2, and then I realize that the answer is 9. And of course, this is correct, because if x is approaching 2, then x plus 7 will approach 9. For example, when x is 1.99, then the x plus 7 is 8.99. And when x is 2.01, then x plus 7 is 9.01. So you can see that whenever x approaches 2, x plus 7 will approach 9. So plugging 2 worked here. Now, what happens when the problem is not that simple? So let's look at this example. Limit x approaches 3, and I have x squared minus 9 divided by x minus 3. So let's say that was the first problem. This is the second one. Now, if I try to do the same, plug x equal to 3, then I'm really looking at this expression. Limit x approaches 3. Now, or I can just say, let me write it here. 3 square minus 9 over 3 minus 3. And this happens to be 9 minus 9, 0 over 0. Now, that cannot be our answer, because 0 over 0 is something that's not a number. Which means plugging x equal to 3 did not work here. It worked here. What was the reason? Well, before we get into the reason, let me first talk about simplifying fractions from elementary school. So if I have something like 10 divided by 4, then I say that they're both even numbers, so 2 goes into that, and I divide each of them by 2. So I'm going to write 10 as 2 times 5 and 4 as 2 times 2. And I remove the common factor 2, and the answer is 5 over 2. Notice, you can remove any number. Now, if I were to think limit x approaches 3, x squared minus 9 can be factored. It's a difference of squares. So you can factor that as x minus 3, x plus 3. And in the denominator, you have x minus 3. So notice that x is never equal to 3. It's getting close and close to 3, but it is not equal to 3. So it's okay to divide both numerator and denominator by x minus 3. Like we could divide both numerator and denominator here by 2, because 2 is not 0. Now, you cannot divide both by 0, so it's okay to divide. Now, then your expression simplifies to this, x plus 3, and now if you plug x equal to 3, you get 3 plus 3 equal to 6. So sometimes you can plug right away, but sometimes you have to do some algebra or something, some trigonometry or something, and rewrite this expression. So this expression works because x is never equal to 3. So is this fraction same as x plus 3? Not quite. X square minus 9 over x minus 3 is almost x plus 3. The only time it's not is when x is equal to 3. At x equal to 3, this is not even defined. So when you look at the graphs of both of these functions, so let me write down f of x equals x square minus 9 over x minus 3, then its graph is pretty much x plus 3, which means has a y-intercept of 3 and has a slope of 1. So that looks something like this, except when x is 3, this function is not even defined. So there is going to be a hole in the graph. So this is the graph of this function. Now, on the other hand, if you were to do g of x equals x plus 3, its graph is going to be a straight line without any hole. So this is a straight line. We all know that, x plus 3. This is almost x plus 3, but not quite. At x equal to 3, this is not defined. So to summarize, sometimes you can evaluate the limit by directly plugging in, and sometimes you have to manipulate the given function. You have to, like here, we factored and then divided. So you may have to do some work before you can plug in. And in next video, we'll look at more examples. Until then, have a great day, and I'll see you in the next video. Thank you.